Hello friends, today I will solve a LeetCode medium problem that was asked in weekly contest 401. So the problem says we start with an array A of n integers where a of I equal to 1, and after each second we simultaneously update each element to be the sum of all its preceding elements plus the element itself. So for example, after 1 second a of 0 remains same, a of 1 becomes a of 0 plus a of 1, a of 2 becomes a of 0 plus a of 1 plus a of 2 and so on. So we need to return the value of a of n minus 1 after k seconds. And the answer can be very large, so we need to return it modulo 10 to the 9 plus 7. So let's understand this problem with an example. So I'll consider the first example. So in the first example, it's given that n equal to 4 and k equal to 5. As n equal to 4, the index starts from 0 and goes till n minus 1, that is 3. And I have k equal to 5. So at 0th second, that is the initial value, the state will be 1, 1, 1, 1. This is the array A. So after first second, 0th element will be as it is, that is 1. The value at index 1 will be value of index 1 plus value of index 0, that will be 1 plus 1, that is 2. Then value at index 2 will be sum of index 0 to index 2, that will be 3. Similarly, value at index 3 will be sum of values from index 0 till index 4, that is 4. After second, value at index 0 will be same, 1. Value at index 1 will be sum of 1 plus 2, that is 3. Value at index 2 will be sum of 1 plus 2 plus 3, that is 6. And at index 3 will be sum of 1 plus 2 plus 3 plus 4, that is 10. Similarly, after third second, the value will be 1, then 1 plus 3, 4, then 1 plus 3 plus 6, that is 10, then 1 plus 3 plus 6 plus 10, that is 20. Then after fourth second, the value will be 1, then 1 plus 4, 5, then 1 plus 4 plus 10, that is 15, then 1 plus 4 plus 10 plus 20, that is 35. Then after fifth second, the value will be 1, then 1 plus 5, 6, then 1 plus 5 plus 15, that will be 21, then 1 plus 5 plus 15 plus 35, that is 56. So we can see to compute the current level, we just need the values of the previous level. So here let's say to compute 21, we are doing 1 plus 5 plus 15, that is 21. So the value of 1 plus 5 is stored at the previous index of the current level. So what we can do, we can just add 15 and this 6 here. So it will be 21. Similarly, to compute the current value at index 3, so I just need to add the value at the current index in the previous level plus the value at the previous index in the current level. So that will be 35 plus 21, that is 56, because we need to add 35 plus 15 plus 5 plus 1, and we know that 1 plus 5 plus 15 is already computed and stored at the previous index of the current level, so we can leverage that. So the value will be 21 plus 35, that is 56. Similarly, I will consider the second example. So I'll mark the indexes as 0, 1, 2, 3, 4. As n equal to 5, the index goes from 0 to n minus 1, and there are 3 seconds. So I'll start with second 0, then second 1, then second 2, then second 3. So initially all the values will be 1. After first second, the value will be 1. Then to compute the value at index 1, we'll take the current value at the previous level and the value at previous index of the current level, and we'll just add it. So it will be 2. Then to compute here, I'll just add these two values. That will be 2 plus 1, 3. To compute this index, I'll just add 1 plus 3, that is 4. And to compute this value, I'll just add 4 plus 1, that is 5. I've discussed in the previous example why we just need to add the diagonal values here. So now I'll compute the values after second. The value at index 0 will remain same, that is 1. Then the value at index 1 will be 2 plus 1, that is 3. Value at index 2 will be 3 plus 3, that is 6. Value at index 3 will be 4 plus 6, 10. Value at index 4 will be 10 plus 5, 15. Then I will compute the values after third index. The value at index 0 remains 1. The value at index 1 will be 3 plus 1, 4. Value at index 2 will be 4 plus 6, 10. Value at index 3 will be 10 plus 10, 20. Value at index 4 will be 10 plus 20 plus 15, that is 35. So the answer will be 35. So to solve this problem, we can declare an array of length n, and I will initialize it to values 1. So after first second, the value at index 0 will remain same. The value at index 1 will be, so this is the value of the previous level or the old value, and I know that at the previous index I have the value for the current level. So I just need to add these two values. So the value after first second at index 1 will be 1 plus 1, that will be 2. Similarly, at index 2, I can see this is the value of the previous level or after 0th second, and this is the value after first second. So I just need to add these two values. So after first second at index 2, the value will be 2 plus 1, that is 3. Similarly, after first second at index 3, this is the value after 0th second, and this is the value at the previous index after first second. So I just need to add these two values, that is 3 plus 1, it will be 4. Similarly, after fourth second, and this is the value at index 3 after first second, so I just need to compute these two values, that is 4 plus 1, that is 5. So after second the values will be, the 1 will remain same as 1. At index 1 the value will be 1 plus 2, that will be 3. At index 2 the value will be 3 plus 3, that is 6. At index 3 the value will be 6 plus 4, that is 10. At index 4 the value will be 10 plus 5, that is 15. Then after third second, the value at index 0 remains same, that is 1. Value at index 1 becomes 1 plus 3, that is 4. Value at index 2 will be 4 plus 6, that is 10. Value at index 3 will be 10 plus 10, that is 20. Value at index 4 will be 20 plus 15, that is 35. So after ith second, we are computing the value. So let's say this is DP array. So we are computing DP of j equal to DP of j, that is the value after I minus 1 second plus DP of j minus 1, and the j runs from index 1 till index n minus 1. So DP of j is the value after I minus 1 second, and DP of j minus 1 is the value that is stored after ith second. So now I will code the problem. First I will declare an DP array of size n, then I will fill the DP array with values 1, and I will declare a mod variable. So I will run a for loop from first second till kth second. Then I will run a for loop from index j equal to 1, j less than n, j plus plus. So the value at index j will be dp of j, that is the old value or the value after t minus 1 second plus dp of j minus 1. So this is the value at index j minus 1 after tth second. So at the end, I'll return the value stored at index dp of n minus 1. Now let's run it for the sample test cases. We can see the sample test cases are running fine. Now I will submit it. So it's working as expected. So here I'm running two for loops. So the outer for loops runs k times and the inner for loops runs n minus 1 times. So I can say the time complexity will be big O of n into k, and I'm declaring an auxiliary array of size n. So the space complexity will be big O of n. Thank you.